6 Types of Data in Statistics and Research, Key in Data Science. Video by myenglishteacher.eu. Source, intelspot.com. Understanding the different types of data in statistics, marketing research, or data science allows you to pick the data type that most closely matches your needs and goals. Whether you are a businessman, marketer, data scientist, or another professional who works with some kinds of data, you should be familiar with the key list of data types. Why? Because the various data classifications allow you to correctly use measurements and thus to correctly make decisions. In this video, you will find the most common data types with examples in statistics, research, and data science simply explained. Qualitative versus quantitative data. Number 1. Quantitative data. Quantitative data seems to be the easiest to explain. It answers key questions such as how many, how much, and how often. Quantitative data can be expressed as a number or can be quantified. Simply put, it can be measured by numerical variables. Quantitative data are easily amenable to statistical manipulation and can be represented by a wide variety of statistical types of graphs and charts such as line, bar graph, scatter plot, etc. Examples of quantitative data. Scores on tests and exams, for example, 85, 67, 90, and etc. The weight of a person or a subject. Your shoe size. The temperature in a room. There are 2 general types of quantitative data: discrete data and continuous data. I will explain them later in this video. Number 2. Qualitative data. Qualitative data can't be expressed as a number and can't be measured. Qualitative data consist of words, pictures, and symbols, not numbers. Qualitative data is also called categorical data because the information can be sorted by category, not by number. Qualitative data can answer questions such as how this has happened, or and why this has happened. Examples of qualitative data. Colors, for example, the color of the sea. Your favorite holiday destination such as Hawaii, New Zealand, and etc. Names as John, Patricia. Ethnicity such as American Indian, Asian, etc. There are 2 general types of qualitative data: nominal data and ordinal data. Nominal versus ordinal data. Number 3. Nominal data. Nominal data is used just for labeling variables without any type of quantitative value. The name nominal comes from the Latin word nomen, which means name. The nominal data just name a thing without applying it to order. Actually, the nominal data could just be called labels. Examples of nominal data. Gender, women, men. Hair color, blonde, brown, brunette, red, etc. Marital status, married, single, widowed. Ethnicity, Hispanic, Asian. As you see from the examples, there is no intrinsic ordering to the variables. Eye color is a nominal variable having a few categories: blue, green, brown, and there is no way to order these categories from highest to lowest. Number 4. Ordinal data. Ordinal data shows where a number is in order. This is the crucial difference between nominal types of data. Ordinal data is data that is placed into some kind of order by their position on a scale. Ordinal data may indicate superiority. However, you cannot do arithmetic with ordinal numbers because they only show sequence. Ordinal variables are considered as in between qualitative and quantitative variables. In other words, the ordinal data is qualitative data for which the values are ordered. In comparison with nominal data, the second one is qualitative data for which the values cannot be placed in an order. We can also assign numbers to ordinal data to show their relative position, but we cannot do math with those numbers. For example, first, second, third, etc. Examples of ordinal data. The first, second, and third person in a competition. Letter grades, A, B, C, etc. When a company asks a customer to rate the sales experience on a scale of 1 to 10. Economic status, low, medium, and high. Discrete versus continuous data. As we mentioned above, discrete and continuous data are the 2 key types of quantitative data. In statistics, marketing research, and data science, many decisions depend on whether the basic data is discrete or continuous. Number 5. Discrete data. Discrete data is a count that involves only integers. The discrete values cannot be subdivided into parts. For example, the number of children in a class is discrete data. You can count whole individuals. You can't count 1.5 kids. To put it in other words, discrete data can take only certain values. The data variables cannot be divided into smaller parts. It has a limited number of possible values, for example, days of the month. Examples of discrete data. The number of students in a class. the number of workers in a company, the number of home runs in a baseball game, the number of test questions you answered correctly. Number 6. Continuous data. Continuous data is information that could be meaningfully divided into finer levels. It can be measured on a scale or continuum and can have almost any numeric value. For example, you can measure your height at very precise scales, meters, centimeters, millimeters, and etc. You can record continuous data at so many different measurements: width, temperature, time, etc. This is where the key difference between discrete types of data lies. The continuous variables can take any value between two numbers. For example, between 50 and 72 inches, there are literally millions of possible heights: 52.04762 inches, 69.948376 inches, and etc. A good great rule for defining if data is continuous or discrete is that if the point of measurement can be reduced in half and still make sense, the data is continuous. Examples of continuous data: the amount of time required to complete a project, the height of children, the square footage of a 2-bedroom house, the speed of cars. Conclusion: all of the different types of data have a critical place in statistics, research, and data science. Data types work great together to help organizations and businesses from all industries build successful data-driven decision-making processes. Working in the data management area and having a good range of data science skills involves a deep understanding of various types of data and when to apply them. What type of data do you use? Leave a comment and share it with us all. Don't forget to subscribe. See you in the next video.